All right, so I'm going to go back over everything I did real quick because I didn't record from the beginning. So we have two functions. F of x is x minus 3. G of x is the square root of x minus 1 plus 5. You can look at the graphs to determine the domain. This one's just a line, so your domain is negative infinity to infinity. The square root function always has a start point, so you can look at that one and see that your domain is from 1 to infinity. When we added the two functions together and combined like terms, we get this. And to find the domain, you want to go back up here for the rules for the domain of a square root function. And it says to find the domain, set the radicand greater than or equal to 0 and solve. So for domain, we only cared about that part underneath the square root. We set it greater or equal to solve. For this domain, will we get the same domain or a different one? Okay, we're going to do the process again. Let's see what we get. So we're going to take the part underneath the square root, x minus 1, set it greater than or equal to 0, and then what do we add to both sides? 1, good. Plus 1, plus 1. So did we get the same domain as the first one? We did, yeah, because all that really matters in domain is the part under the square root. So remember, this is the answer. This is the domain. All right, Riyadh, are you taking notes with us? Awesome. Okay, this one says do g of x divided by f of x. So on the top, we're going to put g of x, which is still this. And on the bottom, we put f of x, which is this. And there's really nothing that simplifies in that. Because of the division with a plus and a minus, you can't simplify that. So that's the answer. And that was pretty easy to just put the functions in there exactly how it said. But we do have to determine the domain. There are only two things that are going to affect your domain. One of them is a square root. The other one's the denominator. So for the square root, we've already done this twice. We already know from the square root that x has to be greater than or equal to 1. So x can't be negative 3 or negative 2. It can't even be 0. It has to be a number that's greater than or equal to 1. But now we also have a denominator. So if you go back up to the top, it says, if you have a denominator, the denominator cannot equal 0. Are you allowed to divide by 0? No, you can't divide by 0. This is why the denominator can't equal 0. So I also know that x minus 3 can't equal 0, which if I solve that gives me x can't equal 3. So x can be any number greater than or equal to 1 except not 3. So x could be 1, x could be 2, not 3. X could be 4, 5, or 6, any of those numbers. Okay? So one way you can write this in interval notation is you could say that the domain is from 1 up to 3, not including 3, and then from 3 to infinity. Another way to say it is just what we had down here. Greater than or equal to 1, but not 3. All right, number 4, luckily, it says domain, but it's really not a domain problem, so we're not going to worry about domain there. So we don't always have to worry about domain. All right, do you need any more time with 1, 2, and 3 before we move on? Show me how many minutes you need before we move on. Okay.
20-something minutes.
That was a good one. All right, we're going to move on in 3 minutes, so make sure you have these 3 down. I'm going to come around. If you're ready for the next one, I'll give you a head start on that one.
Hey, I mean, can you scoot in?
Yeah. Try to catch up on notes, okay? I mean, did you finish?
Finish
The three? Those three?
No.
Do you have a question?
No.
Try to finish.
No.
Thank you. All right, the next one's really straightforward. It says g of 5. So what we're going to do is we're going to put 5 into function g for the x. So I'm taking function g, and I've got square root. Instead of x, we're going to put 5, minus 1, and then plus 5 outside the square root.
So it'd be 5 minus 1 first.
Yeah, but there's a square root on the 5 minus 1. So first we do 5 minus 1, what do we get? 4. So I have square root of 4 plus 5. Square root of... It is.
What are you getting the square root of 4 from?
So I did 5 minus 1,
Okay.
and I got 4. And then what is the square root of 4?
2.
Very good. Final answer? Very good.
So g equals 7?
So g of 5 equals 7. So that means when 5 is the input, 7 is the output.
So g5 equals 7?
Mm-hmm. All right, so putting a number into a function is pretty easy. You've been doing that for a while. Sometimes you have to put an expression into your function. So that's like this one, number 5. So let's look at function f. And what we're going to do is replace the x with a minus 5. So instead of x, we write a minus 5. And then we also write the minus 3.
What's your favorite JoJo bar?
So x minus 3.
So x minus 5 minus 3. Can I combine any like terms?
Yeah, -5, -3.
Very good. So I get a minus 8. Good. All right, I'm going to come around, make sure you guys are ready because the next one is a little bit complicated. I want to make sure you're ready. Okay, so f of g of x means that you're going to replace the x with g of x. So instead of x, you write g of x, and then you write minus 3. So instead of the x, I wrote g of x. Now g of x is this function. So in the next step, you replace g of x with this function. So we're going to have square root of x minus 1 plus 5, and then minus 3. So see that g of x was all of that. And then I just brought down the minus 3. So now I need to combine 5 minus 3. 2. Good. Okay. Now I believe on the back we're just going to have practice problems, nothing new, so I'm going to let you work independently on those, but I'm just going to double check real quick. I'll put this back in just a sec. So on the back, yes, we're doing adding, subtracting, multiplying, dividing, and then substituting in. So remember there's a new f and a new g on the back. I'm going to come around and see how you're doing on that, and I will record when I go over that. Okay, if you're not sure what a function looks like, you can always graph it on your calculator, but you might know by now that a squared function is going to be a parabola, and mx plus b is going to give you a line, and both of those functions have a domain from negative infinity to infinity. If you ever have to guess on domain, negative infinity to infinity is a good guess. So then we're going to add the functions together. X squared plus 5 plus x minus 1. And what like terms did you combine?
Positive 5. No, positive 5 negative.
And what'd that give you? 4. Good. A lot of people wanted to combine the x squared and x, and I know why, because in our last unit we were always multiplying those, and then they did combine. But in this unit, if we're adding them, then they don't add because they're not like terms. So that's just x squared plus x plus 4. And then this is also a quadratic equation. If you're not sure, you can graph it and see, but it's going to also make a parabola. So what's our domain? Negative infinity to infinity. Good. All right, we're going to subtract the functions. So x squared plus 5 minus x minus 1. Notice that when I subtract, I always put the second one in parentheses so I remember to distribute that minus. So it's going to become minus x but plus 1. So x squared plus 5 minus x plus 1. And when I combine the 5 and the 1, what do I get? 6. Good. Okay. What? Yes, it's because it's a minus that I distributed it. You're right. What kind of function is this? Is that, it is quadratic. Good job. It's quadratic as the biggest exponents too. And what's the domain going to be?
Infinity, negative infinity.
Sure, but always do the smallest one first, okay?
God,
So-
my guess game is on the roll right now.
Negative infinity to infinity. Okay, so if you saw that on a quiz or a test, the adding and subtracting should be like a free point because it's not that bad. But now we're going to multiply, so there's a little bit more work to do. We got to distribute. We have x squared plus 5 times x minus 1. And now we have to distribute. What do we get when we do x squared times x? X cubed. Beautiful. X squared times negative 1. Negative what? Negative 1 x squared. 5 times x?
5x.
5x. And 5 times negative 1. Negative 5. Are there any like terms to combine? They're next to each other, but if this one has an x and this one doesn't, then we can't combine them. So I think that we're actually done, which is good. No more to do. Who knows what this is called if it's to the third power?
Cube root or something?
Close. Cubesicle. What is it? Cubic, yeah. Cubic. Remember, cube root is the one that is like a square root, but it has a 3 in it. This is a cubic function, and you can graph it on the calculator if you're not sure what it looks like, but it looks a little like this. And so this arrow is pointing to what? Negative infinity. And this one? To go positive infinity. So we haven't had any interesting domains yet, but I think we'll get one in the next one. All right, f of x goes on the top. G of x on the bottom.
Are you laughing about nothing? Absolutely.
Division cannot cancel out addition or subtraction. Division can only cancel out multiplication. And since nothing is being multiplied here, we can't cancel anything. So this is our final answer. But we do have an interesting domain because we have a denominator. So look back at the front of the notes. On the front of the notes, it says, if you have a denominator, the denominator cannot equal 0. So this cannot equal 0. X minus 1 cannot equal 0. So if I add 1, what can x not equal? X cannot equal 1. So this is the answer, but that's our domain. If it asks for the domain, you got to put it. There'll be some questions that ask for it and some that don't. Okay. f of a minus 3. In this one, we're going to go to function f, and we're going to replace the x with a minus 3. So instead of x squared, it's a minus 3 squared. And then we have the plus 5. Everybody, even my pre-calculus students, they always just want to square each term, but it doesn't work. It doesn't give you everything that you get out of a minus 3 squared. So you have to do a minus 3 times a minus 3. Then we're going to distribute a times a and a times negative 3. And then negative 3 times a and negative 3 times negative 3. And then I'm going to bring down the plus 5.
Where were you?
Alright, combine like terms. What can I combine with negative 3a?
Actually,
The other negative 3a, thank you.
there's no passage, just like
It's just the clipboard. What can I combine with a 9? The 5. Okay, Mervin, what kind of equation is this? Linear, quadratic, cubic? What do you get?
Linear.
Well, the highest exponent is 2, right?
It's cubic.
Close.
Of course.
Other way. Quadratic. Yeah, so if the highest exponent is 2, it's quadratic, okay? So it's going to be a parabola, and it's going to have a domain of all real numbers again. So remember, the only time it's not going to be all real numbers is if you have a square root or if you have a denominator. We're going to put a plus 7 into function g.
so it'd be like square root.
Yeah, but we don't have a square root here. So g is equal to x minus 1. So it's going to be a plus 7 minus 1.
What does that equal sign with the line mean again?
Not equal to.
Not equivalent?
And then we get a plus 6. And that one just has a degree of 1. So what kind of equation is that? Linear. Good. So it still has a domain of all real numbers. And we'll do 1 on the bottom, and then we're going to grade ourselves for the day. So on the bottom, I'm doing g of f of x. So that means I have to take function g, which is x minus 1. And instead of the x, I'm going to put something in there. So x minus 1, except I take the x out and I put in the f of x. F of x is x squared plus 5. And then subtract the 1. And combine like terms. So I have another parabola.
Miss Rock, is different.
Sorry. I have another parabola. So another domain of negative infinity to infinity. If you worked ahead and did problem 8, that one took a little bit more work. But we're not going to get to that one today. So I want you guys to finish up through 7, and then you can grade yourself.